नका नका नाही रे. Hello guys, so this is second theoretical part of our phase 2. So we have seen that there are a lot of exceptions that we have to handle in phase 2, but the more important mechanism that we have to study about is paging mechanism. So we know that our physical memory is very limited. Our physical memory is very limited in case of our phases because they are primitive implementation of any operating system. But the more important part is that there may exist programs which are greater than the physical memory itself. So what can we do in that case? So the option that we are provided with is the use of virtual memory. So virtual memory allows us to load the programs that are greater than the physical memory itself. But the advantage of virtual memory is that only the part of the program that is required to be executed is loaded into our physical memory. But can we talk in such general terms that part of memory should be executed or part of memory should be loaded? But no, because it won't be technical or jargonic in sense. So what we have called it is a mechanism known as paging mechanism. So paging mechanism allows us to load the part of the code or load the part of a particular program that is only required at that particular instance. Suppose I have the code that is of 100 units and my physical memory is of 50 units. So in that case, for each and every instance of my program, whatever part would be required, only that part of my code will be loaded into my physical memory. As simple as that. But you must be thinking that, okay, we know the theoretical part, but how is this implementation done in our phase 2? So, when we talk about the implementation in terms of phase 2, so our physical memory, our physical memory or main memory is of 300 into 4. That is 300 words, right? Because each word is of 4 bytes. And our virtual memory is of 100 into 4. That is 100 words, and each word is of 4 bytes in all the cases. But here the more important part is that we know that physical memory here is of 30 blocks and virtual memory here is of 10 blocks. So how is paging getting executed? Because the mapping should be done in such a way that entire physical memory should be utilized and virtual memory should be accessed easily. So in that case, what we do is we execute paging mechanism. So how is paging mechanism happening? So I would easily make a flowchart. My bad. Okay. We are starting. Then we are generating a random number. After generating a random number, what we are doing is just multiply that random number with 10. Suppose that random number is r, so r into 10. But here is one thing that you have to remember always, that the random number that you are generating should be within 0 to 29. If the number exceeds it, then there is no use case in our case. So we have to remember that the number that is going to be generated should exist within 0 to 29. And once the number is generated, that number is to be multiplied with 10. And what would happen if we are multiplying it with 10? So the virtual memory that is of 100 bytes, that is of 100 words, would be mapped with the physical memory or main memory that is of 300 words. Now, after doing this, just check if the address that is generated after multiplication that address is going to be pointing out to a particular page. Means that address is the address of page itself. Now, if that page is used, then you have to reiterate our thing. You have to reiterate our thing. Our thing means you have to reiterate this algorithm. But, sorry, my bad. Hmm. But what if? What if my page is not used? So I know that I can do whatever I want to do in that space. And now what I would do is I would choose that page and there would exist my page table. So this is the paging mechanism that we have to consider while we are implementing phase 2 of operating system.